Language translation is a critical component of natural language processing (NLP) solutions. It involves converting text or speech from one language to another while preserving the original meaning, tone, and context. This process is essential for enabling communication across different languages and cultures, making information accessible to a global audience. In the context of NLP, language translation leverages advanced algorithms and machine learning models to achieve high accuracy and fluency. The history of language translation dates back to ancient times when scholars and scribes translated religious texts and literary works. Over the centuries, translation methods evolved from manual, labor-intensive processes to more sophisticated techniques. The advent of computers in the 20th century marked a significant milestone, leading to the development of machine translation systems. Early systems relied on rule-based approaches, but modern advancements have shifted towards statistical and neural network-based models. Rule-based translation systems were among the first attempts to automate language translation. These systems use a set of linguistic rules and dictionaries to translate text. While they can handle simple sentences and provide grammatically correct translations, they often struggle with idiomatic expressions, context, and nuances. Despite their limitations, rule-based systems laid the foundation for more advanced translation technologies and are still used in specific applications where precision is paramount. Statistical machine translation (SMT) emerged as a significant improvement over rule-based systems. SMT models use large bilingual corpora to learn translation patterns and probabilities. By analyzing vast amounts of parallel text data, these models can generate more accurate translations. However, SMT has its challenges, such as handling rare words and maintaining fluency. The introduction of phrase-based SMT further enhanced the quality by considering longer sequences of words, but it still fell short in capturing deep contextual meanings. Neural machine translation, NMT, represents the latest advancement in language translation technology. NMT models use deep learning techniques, particularly neural networks, to understand and generate translations. These models can capture complex patterns and contextual information, resulting in more fluent and accurate translations. NMT systems, such as Google's Transformer model, have set new benchmarks in translation quality. They can handle idiomatic expressions, slang, and nuanced meanings more effectively than previous methods. NMT systems consist of several key components: the encoder, the decoder, and the attention mechanism. The encoder processes the input text and converts it into a series of vectors representing the meaning. The decoder then generates the translated text from these vectors. The attention mechanism allows the model to focus on relevant parts of the input text during translation, improving accuracy and fluency. These components work together to produce high-quality translations that closely match the original text's intent and tone. Training NMT models requires large datasets of parallel texts in the source and target languages. These datasets are used to teach the model how to translate by exposing it to various sentence structures, vocabulary, and contexts. The training process involves optimizing the model's parameters to minimize translation errors. Techniques such as transfer learning and fine-tuning can further enhance the model's performance by leveraging pre-trained models and adapting them to specific translation tasks or domains. Despite significant advancements, language translation still faces several challenges. Ambiguity, idiomatic expressions, and cultural nuances can be difficult for models to handle accurately. Rare words and low-resource languages also pose challenges due to limited training data. Additionally, maintaining the original text's tone, style, and context requires sophisticated models and careful tuning. Addressing these challenges is an ongoing area of research in the NLP community, with continuous improvements being made to enhance translation quality. Language translation has a wide range of applications across various industries. In business, it enables companies to reach global markets by translating marketing materials, product descriptions, and customer support content. In healthcare, translation services facilitate communication between patients and healthcare providers who speak different languages. In education, translated materials make learning resources accessible to non-native speakers. Additionally, language translation plays a crucial role in international diplomacy, legal proceedings, and media localization. ethical considerations are paramount in language translation. Ensuring accuracy and avoiding bias in translations is critical, as mistranslations can lead to misunderstandings and misinformation. Translators and developers must be aware of cultural sensitivities and strive to produce translations that respect the original text's intent and context. Additionally, the use of machine translation raises concerns about data privacy and security, as sensitive information may be processed by translation systems. Addressing these ethical issues is essential for building trust and reliability in translation services. The future of language translation is promising, with ongoing research and technological advancements driving continuous improvements. Emerging trends include the integration of multimodal translation, where text, speech, and images are translated simultaneously. Advances in artificial intelligence and machine learning are expected to enhance translation accuracy and fluency further. Additionally, efforts to develop translation systems for low-resource languages and dialects are gaining momentum, aiming to make translation services more inclusive and accessible to diverse populations. Language translation is a vital aspect of natural language processing, enabling communication across linguistic and cultural boundaries. From historical methods to modern neural machine translation, the field has seen significant advancements. While challenges remain, ongoing research and technological innovations continue to improve translation quality and accessibility. As we look to the future, ethical considerations and inclusivity will play a crucial role in shaping the development of translation technologies. By understanding and addressing these aspects, we can create more effective and reliable translation solutions for a global audience.